Question 2. A metal ring of width W is made by first cutting a circular disc and then cutting a circular hole exactly in the center of this disc. This is shown in the diagram. This is the diagram. A machine produces many of these rings each day. The diameters of the discs are normally distributed with mean 30 centimeters and a standard deviation 0.8 centimeters. A. Find the distribution of radii of the discs. Let D follows normal distribution with mean 30 centimeters and a standard deviation 0.8. Let R equals D over 2. So we have E of R equals 1/2 times 30 equals 15. And variance of R equals variance of D over 2 equals 1/2 squared times variance of D is 0.8 squared equals 0.16. So R follows normal distribution with mean 15 and variance 0.16. The radii of the holes are normally distributed with a mean 12 centimeters and a standard deviation 0.25 centimeters. Calculate the probability that the width of a normally chosen ring is less than 2.5 centimeters. Let R sub H follows normal distribution with a mean 12 and standard deviation 0.25. Also let W equals R minus RH. So E of W equals 15 minus 12 equals 3. Variance of W equals 0.16 plus 0.25 squared equals 0.2225. So W follows normal distribution with the mean 3. Variance 0.2225. In other words, the sigma equals square root 0.2225. We are looking for probability of W less than 2.5. Let's go to normal CDF. Lower bound is negative infinity. Upper bound is 2.5. Mean is 3. Standard deviation is square root 0.2225. Enter. Answer is 0.145. Let's go to question 3. Two fair four-sided dice, one red and one green, are thrown. For each die, the faces are labeled 1, 2, 3, 4. The score for each die is the number which lands face down. List the pairs of scores that give a sum of 6. Let's list all the outcomes. From this list of outcomes 6, 6, 6. So pairs of scores that give a sum of 6 will be 4, 2, 3, 3, 2, 4. The probability distribution for the sum of the scores on the 2 dice is shown below. Find the values of P, of Q, and of R. From these outcomes, we find only 1, 2. The possible outcomes is 16. So P equals 1 over 16. For Q, we found 2 3s. So Q equals 2 over 16. For R, we found 2 7s. So R equals 2 over 16. Let's go to C. Calculate the expected sum of the scores on the 2 dice. The expected sum equals each value of the sum times its probability, then add them up, which means 2 times 1 over 16 plus 3 times 2 over 16 plus 8 times 1 over 16 equals 5. Fred plays again. He threw 2 fair 4-sided dice 4 times. He wins a prize if the sum is 5 on 3 or more thrown. Find the probability that Fred wins a prize. This will be binomial distribution. N equals 4. Probability equals 4 over 16, which is 1 over 4. Let X follows binomial distribution with 4 and 1 over 4. We are looking for probability of X greater than or equal to 3. Let's go to binom CDF. Number of trials is 4. Probability of success is 1 divided by 4. Lower bound is 3. Upper bound is 4. Enter, enter. Answer is 0.0508. E. John plays the game 2. Find the probability that both of them win the prize. So we are looking for the probability that these 2 events happen at the same time. And these 2 events are independent of each other. So probability will be 0.0508 squared. Answer is 0.00258.